Next we will see the terms used in cams. Mostly in radial cams we have some different profiles. We will take an example of radial cams. Terms used in radial cams. We can take terms used in radial cams. I am going to draw a cam profile. What is the meaning of radial cams? The follower motion and the cam will be in line in the same axis. What are the important terms we are going to use in the cam profile? To take the cam. First you draw a shaft here, a circular shaft. Next, we have to draw a base circle. It is our base circle here. We can mark here. This is cam shaft. It is our base circle. What is the meaning of a base circle? The base circle is our base of any cam profile. It is where the profile starts and ends in the base circle. It is the basic circle where the cam profile lies. The shape of the cam profile lies here. The next one is a prime circle. It is our prime circle. Mark here. Prime circle. The prime circle is the circle which is somewhat higher than the base circle. The diameter is somewhat higher than the base circle. For the prime circle mostly will be for a roller follower only. For roller follower you are going to draw the prime circle. For other profiles, for example, knife edge follower, flat faced follower, the base circle. For that follower, the base circle acts as the prime circle. It acts as a base. But for roller follower, the prime circle is the basic circle where the center point of the roller lies. Therefore, by having the center point of the roller, this is the center point of the roller, you have to draw a roller follower. You have to draw our roller follower. It is our roller follower. The roller follower lies on the center of the prime circle. It is the offset distance. It is the offset distance. We will take it as a translation motion of the follower. Offset distance carried out by the follower. It is from this position the follower will move up and down according to the cam profile. Therefore, the important points is camshaft, where the camshaft is connected to the directly to the driven shaft or the flywheel. From the flywheel, the energy is taken to the camshaft. The camshaft is made to rotate in clockwise or anti-clockwise. It is connected to the base circle. The base circle is the circle forming the base of the cam profile, and then prime circle is drawn with the center point of the roller. And also the prime circle has the diameter larger than the base circle. It is the main important point. Then some important points is pitch point. Another important point is pitch point, pitch curve, and then pressure angle. These are some important terms used in cam profile. What is this pitch point, pitch curve, pressure angle? The pitch point is nothing but the point having a maximum pressure angle. The point having a maximum pressure angle. What is the pitch curve? The curve. The pitch curve is nothing but the curve joined with all the pitch points. For example, I am drawing this profile. I am drawing some roller from here. These are some pitch points having the maximum pressure angle. You can see here from this point there will be a profile will be, all the rollers will be here. This all will be the rollers placed like this. You have to draw the cam profile like this. You can see the cam profile is gone. Like this is our cam profile. You can say it is our cam profile. And the curve drawn against this curve, the circle or the curve drawn by using this pitch curve, you can say it is our this curve is called as a pitch curve. Pitch curve is nothing but the point joining all the following motion. It is the pitch curve. And the circle drawn to the pitch point, and also the circle drawn to the pitch point is called as a pitch circle. There is also a pitch circle there. The circle drawn to the all the pitch points is also called as a, somewhat confusing this. Please remember all these points. It is called as a pitch circle. Pitch curve is nothing but the curve joining all center points of the follower or the roller follower. Circle is, pitch circle is nothing but the circle drawn by using the center point of this all the rollers is called as a pitch circle. There will be a maximum pressure angle here. We can say here there will be a maximum. When you draw a normal to the pitch point, we can see this is the maximum pressure angle. What is the meaning of pressure angle? The angle normal to the pitch point. When you take the angle normal to the pitch point, there will be a pressure angle. We should not exceed the maximum pressure angle. This will be the maximum pressure angle. We should not exceed the maximum pressure angle. Otherwise, the follower will that is getting jammed condition. Therefore, the maximum, we should not exceed this maximum pressure angle for the cam mechanism. This is our maximum pressure angle. The curve drawn, it is nothing but a pressure angle is nothing but the angle between the pitch point and the normal to the curve, cam profile. These are some important points used in the terms used in cam profile. You can say that is a radial cams. There will be mainly there will be a camshaft, there will be base circle, there will be a prime circle, there will be a pitch circle, there will be a pitch curve, there will be pitch point, there will be a pressure angle and the cam profile. Finally, there will be a cam profile. These are some important terms used in the radial cams. Next, coming to motions of flowing. Motions of flowing. There are 4 types of motion. It is also called as a displacement diagrams. This follower makes some motion. Therefore, you can also call it as a displacement diagram. The follower follows some path. The follower has some follower motion should take place. Therefore, it follows some displacement path. Therefore, the first one will be a uniform velocity. The path followed by the motion followed by the follower is under uniform velocity motion. With the uniform velocity, the simple harmonic motion. Simple harmonic motion. Then uniform acceleration and retardation. Uniform acceleration and retardation. Then cycloidal motion. The fourth one is cycloidal motion. The following motion as categorized into uniform velocity, simple harmonic motion, uniform acceleration retardation, then cycloidal motion. Is all this motion, that is follower motion, has some displacement diagram, has some form of displacement diagram. We will see one by one. First one we will take a uniform velocity. In uniform velocity, we have to draw the displacement diagram. Before going to displacement diagram, there are some important points in the displacement diagram. This box will be drawn with a height of offset distance. The height will be the displacement of the follower. We have to know the displacement. Then in the problem they will give the displacement. We have to design the cam profile for the displacement of the given follower motion. Therefore, they will give the offset distance or the follower motion distance. It is S. It is called as a motion of follower. Motion of follower. They will give some height of the follower motion, follower translation motion. Then you have to remember there are some important points here to remember. That is outward stroke of the cam. Outward stroke of the cam, return stroke, and the dwell period. What is the meaning of dwell? DWELL. Dwell is nothing but the rest period. It is called as a dwell. And then return stroke. Return stroke of the follower, and the remaining will be a dwell period. The total angle of the follower will be, the total angle taken by the cam will be, we know the total rotation of the cam will be, since it is a shaft, the total angle made by the cam profile will be 360 degree. They will give some outward stroke where the follower will have some operation from opening conditions. For example, if you take IC engines, there will be the wall will be open condition. The wall will be slightly opening when there is an outward stroke. And in the dwell period, there will be rest period. The wall will be opened in the distance, in this angle of a cam. The next in return stroke, the wall will be closing in the return stroke. This is some important angle they will give. For example, they will give 90 degree outward stroke of the cam profile. Then dwell period is rest period. Then return stroke is some 30 degree. Sorry, dwell period is 30 degree and the return stroke will be 60 degree. Therefore, the remaining angle we know. Total angle is 360 degree. 60, 30, 90, 90, 180. What will be the remaining angle?
180.
Remaining angle will be 180. Total angle is 360. The remaining angle will be 180. It is also a dwell period. The wall will be closed in this position for the remaining cam period. Therefore, in this cam period, in this profile, the follower motion will take upward direction. The wall will be opening and closing in outward return stroke, and there will be motion in this path of the displacement diagram. And also in uniform velocity, when you take the uniform velocity, there will be a motion will be uniform distribution. The value of the displacement will be in the uniform direction. The wall will be opening in an upward direction. Suddenly it will open and it will be closing suddenly with a uniform velocity. The velocity will be uniform. When you draw the displacement, there is a chart. You can see the velocity chart and the acceleration chart separately. The velocity will be, there will be movement of this velocity, and there will be a downward motion of the velocity here. It is our velocity chart showing the movement of this following. In the second type, that is simple harmonic motion, the following motion will take in a simple harmonic nature in the form of a sine curve. In the form of a sine curve. In simple harmonic motion, we can see a sine curve in the displacement diagram. There will be upward and downward motion in the same displacement diagram. It is our outward It is our dwell period and it is our return stroke period. It is called as a outward stroke. It is our dwell period and it is our return stroke. It are and the remaining things are dwell period here. Therefore, in simple harmonic motion, we have to draw a semicircle. We know the stroke of the follower also. They will give the stroke of the follower. It is our stroke of the follower of the most of the follower. Therefore, we have to draw a semicircle here and split the semicircle into 6 equal parts. Divide the semicircle into 6 equal parts. Then you have to draw an horizontal line from all the points, all these points. You draw a horizontal line from all these points. And then split the outward stroke into 6 equal parts. Similarly, you split the outward stroke into 6 equal parts. You draw a vertical lines. Take it as a 1 dash, 2 dash, 3 dash, 1 dash, 6 dash. You draw a vertical line by these points, all the points. After drawing horizontal and vertical lines, these all the points will meet at a point. These all the vertical horizontal lines will meet at a point. This forms the curve, our simple harmonic curve. You join all these points to form a smooth curve. Therefore, the nature of or the displacement of the follower will takes in the smooth manner. There will not be any deviation. It takes in the curve nature. Therefore, when you draw the velocity diagram, velocity value, there will be, we can see here, there will be a most of the follower takes place in smooth manner. There will not be any noise in the follower. There will be a smooth manner. It takes the acceleration. We can see there will be a smooth nature of this acceleration. There will be a upward and a downward acceleration of this follower motion. It is the simple harmonic motion. You can see a smooth curve, both upward and downward motion in the same outward stroke period. And also return stroke period, we can see the sine curve in the same manner. It is called as a simple harmonic motion. Next we will see the uniform acceleration retardation. Third one. The third one is a simple uniform acceleration retardation. For this diagram, once again you have to draw the displacement diagram by having a outward and return stroke, same way and same manner. This angle is outward stroke, this angle is dwell period, and this angle is return stroke. The remaining things are dwell. In uniform acceleration retardation, there will be an, when you draw the velocity diagram, there will be an upward and downward. You can see both upward in a manner. Sudden upward and sudden downward. Sudden upward and sudden downward motion of the follower takes place. How to draw this? How to draw this displacement diagram? Once again, you split the outward stroke into 6 equal parts and return stroke into 6 equal parts. Then you join the midpoint alone. You split the midpoint into 6 equal parts. Then you draw the diagonal. First you join the diagonals. Bottom points you join with the bottom 2 points. And upward 2 points you join with the other 2 points. And also you join all the, you draw the vertical lines also. You draw the vertical lines. They will cut at the point. In the middle line, you cut into 6 equal parts. Similarly, to join the diagonals, upper 2 points with the uppermost end point and bottom 2 points to the bottommost point. There will be meeting points here. When you join all the values, you can see here meeting points here. This is our first line meeting point, first point meeting point, second point meeting, and the third one meeting here. Therefore, we can join a smooth curve and also in the same manner there will be a meeting points here. It is our uniform axial retardation. There will be a sudden rise and sudden fall in the outward stroke and also return stroke. In most of the cases, that is simple harmonic and the uniform axial retardations are used. In most the IC engines for opening and closing of the valves, we are going to use the simple harmonic motion. That will be smooth operation. And for automation purpose, we are going to use this sudden movements for opening and closing of the valves or some automatic movement of the machinery parts. We are going to use this uniform acceleration retardation.